Hello everyone, welcome to this morning's CPD webinar. My name is Rebecca Kemp, I am the editor of FCNA. Today I'll be joined by Tamlite Lighting's Colin Lawson. Colin is the head of market intelligence at Tamlite Lighting. He has been with Tamlite for over 25 years, amassing an unrivaled wealth of knowledge and experience from the world of light and lighting. Colin carries with him all the education, training and relevant experience necessary to help deliver stunning projects across the country, working alongside and managing a large group of experienced specification and sales engineers. Having presented many webinars for Tamlite before, today Colin will deliver an approved CPD covering all aspects of the common pitfalls with emergency lighting compliance. During this presentation, he will go through regulations and standards, luminaire types, emergency lighting system types, emergency lighting system design, and standby emergency lighting. Colin will also be available to answer questions at the end, so be sure to make full use of his lighting background and understanding. To ask a question, please use the sidebar on the right of desktops where you can type in any queries you may have. For mobile users, it's slightly different. Swipe left to ask any questions and then swipe right to return to the presentation. Right, that's enough from me, so I'm going to hand you over to Colin now. Colin, you're in full control. I'm going to switch off.
Well, thank you, Rebecca. Yes, Colin Lawson here. I'm from Tamlite Lighting, and pleased to have an opportunity to talk to you about a very topical subject, common pitfalls with emergency lighting compliance, and hopefully gives you a broad overview of the challenges we all kind of face on this important subject. So when I think about who the presentation's for, who's it aimed at, there are lots of people involved in either determining what the emergency lighting in a building should be, what standard it should be achieving, who's the responsible people, right through to people responsible for maintaining, looking after emergency lighting. But it's also people designing new buildings, and whether they be consultants or architects, and of course those installing the emergency lighting in buildings. Vital that they've got an understanding of why it's important, what are the guidelines, and why certain products are the way they are. Obviously, as with any presentation, we want to show what the learning outcome is, and we've kind of picked 4 or 5 different areas there that I think touch on the various aspects of emergency lighting. First of all, regulations and standards are the starting point, really, because unlike perhaps traditional lighting, normal mains lighting, emergency lighting has a much stronger regulatory framework to operate in, and so that's very key. Understanding of the luminaire types is very important, as well as the system types and the different system designs that you can have. And there's a small bit that we've got to talk about with standby emergency lighting, because that's that's becoming just as important. Of course, many people have a good, in the audience perhaps have a good understanding of what emergency lighting is, but it's important to recognise that it's there for when the mains power supply is cut off, and under that circumstance, of course, normal illumination fails, and of course that leads to sudden darkness and danger to occupants, just through normal physical danger, or indeed panic, of course, panic station setting. And emergency lighting, as stated, ensures that occupants of a building are able to swiftly and safely evacuate a building. So that's a key function of emergency lighting, and probably the most recognised part of an emergency lighting installation is to get users safely out of a building in the event of that mains failure. There is a secondary aspect, which, as I mentioned previously, which is standby lighting, which is in some certain situations within certain buildings, occupants of the building need to remain in the building for one reason or another. And so standby emergency lighting provides a much improved and higher level of lighting to allow occupants, workers, to remain within their workplace, within their area, within the building, until the power is restored. So if we start with, the regulations and the standards, there are, of course, government regulations that cover emergency lighting in the UK. And as they are enshrined in law, that gives emergency lighting a much tighter legal framework to operate in than you would do with normal mains lighting, where lighting levels typically are recommendations rather than regulations, and it's that difference between those two. BS 5266, 60598 are British standards for emergency lighting, as is 50171. Obviously, the Regulatory Fire Reform Order, has a key part to play in how it allocates responsibility for emergency lighting to certain people within a business or an organisation. There's another standard which is EN 1838, often spoken about within lighting circles. It's all about lighting applications for emergency lighting, and we've not detailed it in this presentation, mostly because 5266 takes a lot of the detail of 1838 into account when it's published. And so it's the most relevant document, and much of what's in there is covered in 5266. So the Regulatory Reform Fire Safety Order 2005 really, and this is a requirement as well. That's a key part of this. It's not a recommendation. This is a requirement, a legal requirement, that the responsible person within the organisation, having control of the building usually, or some degree of control, takes reasonable steps to reduce the risk of fire, and make sure people can safely escape if there is a fire. And as part of that responsibility, then of course they've got to carry out a fire risk assessment, and part of that risk assessment would be identifying escape routes and potential hazards. Once a building has got more than 5 employees, and that's a key number, then that risk assessment must be captured in writing and must be a document available to, for inspection at any one time. And of course, there's also other requirements that health and safety people would talk about, which is that the reviews, the findings are reviewed regularly, as are the rules and guidelines, particularly when there's any change of occupancy, change of use of building. It's vital that those guidelines are the fire safety risk assessment is reviewed regularly. So identifying escape routes and doing all of that is a key part to that risk assessment, and it includes the specific guidance as well within the RFO for health for different applications, whether they be hospitals, schools, residential care homes, transport stations, etc. Lots of different areas are considered within that particular standard. 5266 then actually now covers much more of the fine detail of emergency lighting design, and now we're moving on to the objective escape route lighting. Of course, as a key part of this is to assist the safe exit, and the overriding strategy is to provide appropriate visual conditions and direction finding on escape routes and in special locations. And so as part of that, we've got to ensure that firefighting and safety equipment can be readily located and used as well. So there are guidelines which you'll see on the slide there, which talk about specific light levels. First of all, on escape routes. So escape routes that are up to 2 meters wide, which typically is corridor areas, will require 1 lux on the floor along the center line, and that's a minimum of 1 lux. So every light point across the center line of an escape corridor must be lit to a minimum of 1 lux. Either side of that line it must be 0.5 lux. So that's across the entire width. So those two numbers really are our starting point for lighting design, and that will dictate how many luminaires are used, what kind of output they have, where they're spaced. And so a real professional lighting design would be look into those numbers on the corridor areas. In open areas, the legislation for open areas is 0.5 lux as an average across that area. And so again, forms a major part of any correct lighting design. Two areas which are not always frequently known about are high risk task area, where the illumination level is a lot higher, and that will be normally 10% of normal illuminance. So if in a workshop area or a warehouse area you have 300 lux or maybe 500 lux, then the emergency lighting level provision has got to be for 30 lux average or 50 lux average across that area, with a minimum level of 15 lux across that as well. So that's quite a significant jump up, and requires real involved design work with luminaire manufacturer to make provision for that. And we have had experience in our business of a number of linear or high bay lighting products, and every one of them in that area might need to be emergency lighting product to be able to provide that kind of coverage for what's the fire risk assessment determines is a high risk task area. The definition of high risk task areas can be quite extended. Certainly, obviously, some of the obvious ones with dangerous machinery, whether that be high temperatures in production areas or cutting machines, then a lot of those areas are classed as high risk. And so a failure of the mains lighting that's illuminating those areas down to light levels which in open areas are 0.5 lux is clearly in some cases not adequate, and so the high risk 10% of normal illumines comes into play. And then of course we're into exit signage and making sure that any standalone signage, the areas around those signage are 2 lux as well as an average. So once we've determined our the regulations and the standards, then the next standard that really is very applicable is the standard for the build and the construction and the design of the emergency lighting products. And BS 605982-22 is the British standard for build and quality, technical and testing of emergency lighting products. And of course, there are lots of things that we would recommend clients specifying emergency lighting look for. Some obvious ones, of course, you want it to have some earthing, you need instructions, but also fire resistance and battery performance. You know, they're very key aspects. Photometric performance can be very important as well. Once you're trying to get the light levels down a corridor or a center line, manufacturers would take a lot of time to try and get those spacings to a minimum, to a maximum, so that you know, the install and the cost is minimized, but also to ensure that you get that very even spread and from a design perspective that's needed as well. So lots of different areas. Battery performance is a one that I would point to all the time, because I think that when choices are made about luminaires, then often battery performance can be the biggest area where cost savings are maybe tried to be made, and yet the battery performance is really the critical part of that design. You know, and a fitting that provides a 3-hour emergency lighting duration on initial install might not do that after 12 months, and regular checks and part of the testing regime is such that you need to do that full discharge within that period of time. And battery life is a very topical subject within the lighting industry, and battery warranty as well. Because ultimately, you know, the luminaire needs an adequate battery life to provide that level of illumination at whatever time it's required. And so it's a key part to it. The next standard, BS 50171, is all about central power, battery central power systems, CPS is for short. And the BS 50171-2000 really specifies the general requirements for these battery supply systems, And it's an independent, separate energy supply rather than having localized battery and converter units within the luminaires. And so the system, the network of emergency lighting products are permanently connected to AC supply voltage not exceeding 1,000 volts, and use those as an alternative power supply. So they are designed to, to energize mostly escape lighting in the case of failure. And of course, in doing that, they can also provide backup for paging systems, smoke extraction equipment, and other power units which are critical to, fire prevention and fire safety within a building. So it's an important standard that covers not just, lighting per se, although it's typically, heavily associated with lighting, but there are other considerations with emergency lighting for central power systems. Let's move on and look at luminaire and system types. And, there are many different types that we're now considering. We kind of think about generalizing the emergency lighting products, dedicated emergency lighting products, into two distinct categories. First of all, what we view as maintained emergency lights, and then non-maintained emergency lights. So maintained emergency lighting are products that can be switched on and off and used as a normal product under mains operation. And that could be anything from a linear product to a 600 by 600 or a circular bulkhead on a staircase or in a corridor. And they provide lighting for normal mains operations and can be switched on and off under normal circumstances. When there is an emergency, then a maintained lighting switches over to its battery power supply. And so the light source that's in there, typically these days it's LED, that would now be running a much reduced output because it's only got 12 volts worth of batteries power supply to give it an output. A non-maintained emergency lighting product traditionally is what we call a dedicated emergency lighting luminaire. So similar to the signage exit box that you see on screen there. And this is a luminaire that typically only comes on or can only be switched on in the event of mains failure. So under normal circumstances with normal mains, it's not illuminated at all, not contributing towards any of the mains lighting in a building, either in the corridors or in the open areas. Only comes on when there is an emergency and mains failure. A phrase that's still being used, but now is much less frequently used, was sustained. And sustained emergency lighting products were a product that had two separate light sources within the luminaire, one that was used for mains operation and one that was used for emergency operation. But with the advent of LED, it's removed that requirement generally. And in most cases now, you'll find that there is a single light source in the luminaires, and that either operates under normal mains or under 12-volt battery supply. Obviously, the key aspect to the luminaire types is the duration. Over 98% of luminaires installed in the UK and emergency lighting are for 3-hour duration. In the old days, the duration 3 hours was determined because it was determined that that's how long you would need to consider for the emergency services to turn up at any premises. And so the emergency lighting would stay on for that period of time. And that's just become a very common and traditional way of viewing the specification, and so it's commonplace. Finally, viewing distances. That's an important aspect of the installation, and there's a calculation that helps people determine that, and we'll come to that in a second or two. So there we are. That's a quick summary of what we mean by non-maintained, maintained, and sustained. And typically, as I said, maintains are required in mostly non-residential, so office buildings. Certainly all hotels would provide that, and then darkroom areas as well. So the duration, as I say, one key pitfall perhaps, is the understanding of duration as far as the standard is concerned, because, the code of practice stipulates that it must have a duration of not less than 1 hour. That's actually in the standard, but it's, as I said before, generally it's now accepted that 3 hours is the minimum adequate duration, and that's been commonly adopted by the industry, which obviously goes above and beyond the code of practice. That phrase, going above and beyond the code of practice, is maybe a key principle for many to follow in designing when you're doing emergency lighting design. And typically, there's no problem with technology in being able to supply 3-hour battery life. So finally, the different system types that are out there. So this is moving away from the luminaires, and these are the different types. The vast majority of emergency lighting in the UK is serviced by what we call self-contained light fittings. So these are operating autonomously on their own. In the event of a failure of the energy source, then the beauty of them is that only one luminaire fails at that point, and not the entire system. And it's much more flexible, by definition, really. Luminaires can be added at any point, easily maintained. A failure of one of those only creates a very small point rather than the entire system being disabled. And particularly in larger areas, it's a critical part to consider. There are, of course, other systems and the slave luminaires. Maintenance is generally easier because you're doing at a single point. A slave luminaire can contain fewer components because the power source is generally in a centralized point. So there are fewer components inside the luminaire. But it can be a lot longer to install and more expensive because the power supply has to be connected by a separate cabling to the main supply. So it can have inherent cost additions. And then, of course, there is mains conversion, which can be done, where you ask for an LED modular that has an integral battery pack, and a percentage output can work in an emergency situation. And there are installations across the country where people are adding mains conversion emergency packs with batteries and inverters into an existing luminaire that's already there, and that can be used. It's typically used where there are perhaps failures of dedicated emergency luminaires. So we mentioned viewing distance earlier, and part of the regulation has a viewing distance for the emergency luminaire signage. And there are differences, of course, in viewing distance between illuminated, so self-illuminated products, and non-illuminated external sticky wall signs. So that might be just a legend fixed to a wall that may have some self-illuminating chemical treatment to it, or it might be just the legend on its own. So for an illuminated exit sign, the viewing distance, the maximum viewing distance is 200 times the legend height. So if in the example that we've got there that the legend height is 190 millimeters high, which again is a fairly typical dimension for an exit box, then at that point the maximum viewing distance is 38 meters. And so the design has to consider that and make sure that whichever point in the building you're at on the escape route, that you can see an emergency exit sign from that distance. So if you have a 50-meter long corridor or room, then you would have to make sure that there are 2 exit signs on that, in that room or in that corridor, to cater for a 190 millimeter high exit signage. You'd have a choice then of either increasing the height and the size of the exit signage, or adding a midway legend sign that's illuminated as well along that distance to make sure that the maximum distance isn't exceeded. Generally, our view is that photoluminescent signage is being phased out as we move to LED luminaires, and even though they are able to provide a solution, the signage, the emergency lighting, LED emergency lighting signage is so prevalent and economical these days that we tend to find that it's being phased out quite significantly. If we move on to look at signage in a little bit more detail, there are standards about what that sign should look like. There is an ISO standard now, 7010, which has been adopted, and it's the signage to use on all new builds. So new builds this. That doesn't mean that everybody has to start replacing their signage on an existing installation. The most common use, of course, these days is the use of the down arrow above a final or transient doorway, and the down arrow is now only to be used at the top of a downward staircase. So at all door exit points where there is no change of direction downwards, then the upward signage is the one that should be used to indicate that you're going forwards or ahead. This downward signage was deemed that it was too clear of an indication that you were going downwards. For existing installations, it's important that you've got to match the signs to older standards. So if you're replacing a luminaire in a building, replacing a dedicated emergency luminaire that has a signage on it, then it's critical that that signage matches the style of all of those already in the building. And if that's the old style, then there's no problem, but you cannot mix. So you cannot put a new legend in and not replace all the other legends. So you have to make sure that any replacement product has to match the signage on the existing installation. Again, another pitfall. Let's move on and look at design and concentrating on what we would call capillaries and arteries as far as the design is concerned. Multi-level and multi-directional escape routes. Those are critical areas in any lighting design. So if we move on to escape routes, on any multi-level or multi-directional escape route, the critical emphasis is to highlight any changes. That really is the key aspect for emergency lighting design. We need to consider, first of all, elevation. For every tread on an escape route, multi-elevation, you need to ensure a 1 lux maximum illuminated illuminance on the center. So right up a staircase, each of those treads and steps on a staircase needs to have a 1 lux minimum, as though it was the corridor. The number of luminaires can often be relative to the length of a run, but a proper full professional lighting calculation would be required, obviously on all proposals anyway, but certainly on the staircase, a good design would need to consider that as well. And that 1 lux on the central line applies to the elevation as well. Any change of direction must be highlighted with a point of emphasis. So this typically would be a luminaire at that juncture. So on a corridor there, on the diagram, you can see as you come down that first staircase and the corridor turns to the right, then it's critical that that turn of direction is receives a point of emphasis from the lighting design perspective. And at that point, we would also look clearly for some signage to indicate the change of direction. And each change of direction must be clearly marked within 2 meters of the applicable change. So that's the dimension that we talk about. We've got a very simple example on that diagram, but it could easily be a much different and longer change of direction. So any emphasis must be highlighted, clearly marked within 2 meters of the applicable change. The ratio as well within a lighting design is quite critical. At the maximum illumination level to the minimum must be no greater than 40:1. So that means you cannot light, perhaps as an example, the center line to 80 lux and have 1 lux in a corridor. That ratio is too great. So you've got to keep it within that 40:1 ratio, which means a good spread of luminaires rather than trying to get you 1 lux from a single luminaire, maybe located right in the middle of the corridor. If the level directly below it, which is where it's typically going to be the highest, is 80 lux, and you've achieved your 1 lux at the end of the corridor and maintained that, that isn't good enough. You need to have 2 luminaires to create that. That will clearly indicate that you're going to get an increase above 1 lux, and really that goes back to a point mentioned earlier, that it's often better practice to go above the recommendations rather than just hit them as a minimum, and that 40-to-1 ratio is in there to try and prevent people just complying with that 1 lux minimum. The response time for building compliance for luminaire compliance is very rarely not met. 5 seconds to reach 50% output. This was traditionally in there for all the fluorescent products that took time to get up to full output. LED as a light source operates on 12 volt anyway. Most LED sources are operating at 12 volts, so getting to full output with an LED light source is not really an issue. Color rendering index must be 40 or above. Once again, not a difficult level to achieve, with the vast majority of LED products these days being at 80 or above for their RA. Let's move on to open areas. Sometimes open areas are referred to as anti-panic lighting, and it's there to reduce panic and get the safe movement of occupants to an escape route. This is achieved by, again, the right visual conditions and direction finding. Its first criteria that we think about with open areas is usually spaces over 60 square meters. But again, the practice encourages people to comply that with toilets over 8 meters squared or all accessible disabled toilets. Some areas can, of course, be happily classed as anti-panic, which are below 60 meters. Classrooms and meeting rooms are not typically covered by that, but that doesn't stop the responsible officer building his risk assessment to determine that some classrooms would fall below that. And with the increased emphasis on emergency lighting, there are many now considering to provide emergency lighting in classrooms that are smaller than 60 meters as a measure of going slightly above and beyond the legislation. So the level of luminance is 0.5 lux in the core area, which excludes a half meter edge around the building. Again, there's a 40, not the building, sorry, the room. There is again a 40-to-1 ratio between the maximum and the minimum levels in that area, and the same response time and color rendering requirements that we saw in corridors. So very simple and easily calculable standard to comply there. Let's move on to high risk task areas. We covered this area and determined by the phrase that it's an area designed to safely carry out shutdown tasks, maybe shutting down hot plates, shutting down other high temperature machinery that allows the safe exit for other occupants within that location. And health and safety requirements would easily determine what are classed as high risk areas. Electrical plant rooms, first aid rooms, treatment rooms are typical examples of those. They have their own illumination levels set within the standard. For instance, electrical plant rooms is 15 lux on the task area. So that's typically around 10%. We would normally light a plant room perhaps to 150 lux for normal mains lighting. So the 15 lux applies in there. For a treatment room, that would be a little bit higher, because the treatment room would typically have 300 lux for normal mains lighting. Therefore, 30 lux becomes the light level for emergency lighting in a treatment room. Other areas, moving vehicles, flammable materials, control rooms might also be deemed as high risk. The light levels in those areas would be 10% of what the light level is normally. And that would easily take it well above the 15 lux minimum we would expect in most of those places. Those minimum light levels, of course, must be maintained for a minimum of 30 minutes, up to the full duration 3 hours. So important that those illumination levels, those higher illumination levels, are maintained across that period of time as well. Within the design, there's some consideration for additional areas. These might be lift cars, escalators, toilets or bathrooms that are also included, and pedestrian areas. And illumination levels in the standard are left to individual consideration within this. and that does leave scope for cost cutting. But as I say, I think the emphasis with many establishments is to provide the same lighting level in toilets as they would do in other areas of the building, in corridors and such like. Now, places of entertainment. Careful consideration, of course, for these areas. One of the key areas, particularly from the risk assessment, would be the unfamiliarity of the soundings by people in there, of the surroundings. So we need to consider illuminating the seating, and of course we need to control the lighting so it doesn't detract from the entertainment. So it's a bit of a challenge. The light levels follows typically what we would use in a corridor. So 0.1 lux in seated areas and 1 lux along the aisle and gangways. And that follows with the corridor lighting that we spoke about earlier. So effectively, in a cinema, for instance, they're talking about the line of seats and all of the areas that you would walk along being almost classed as a corridor. 1 lux along the centre line, 0.5 in a central band, and 0.5 either side. The final area really that needs consideration gets considered outside of the building. Once occupants have reached a safe point of safety outside of the building, they're away from the influence of the building, there is a great danger in thinking that their safety no longer needs to be considered. But of course, as an example, persons are not necessarily safe once they've just left the building. They may need to continue to reach the safety collection point. And so there may be an escape route covered and noted on the exterior of the building as well. Particularly if you may be in a fenced compound, just because you are 1.5 meters away from the exit door, which is where the internal emergency lighting regulations cease, doesn't mean that we should no longer consider providing a safe exit route. Any routes required to direct persons to a point of safety must be treated as part of a normal escape route, and therefore the 1 lux minimum level is still required. This becomes a challenge in external environments because clearly some of the building illumination is not sufficient to provide a 1 lux minimum across a centre route of an escape route. So it may be that a column or a building mounted floodlight is needed, and a one that's got a battery backup to be able to provide the emergency lighting. A point of safety may not be to the muster point itself, but it depends on what the fire risk assessment is claiming. So it's important to consider muster points. They're a vital part of the overall design. Another pitfall then, moving on to firefighting, another pitfall that often we see when we look at lighted designs is that fire control and indicating equipment needs special consideration. So the illumination levels that we spoke about down the corridor, the 1 lux down the centre line, or in the open area, the light levels in the open area. If there is firefighting and fire control indicating equipment, that might be the fire alarm control panel or call points within a corridor, then those devices and that equipment needs a separate consideration and requires 15 lux on the task for the full duration. So that really comes into play when we start thinking about the location and siting of either a bulkhead or a circular product or a recessed product in the corridor. We would highly recommend that the location of that is close as possible to the firefighting equipment. And quite often on a design, when we get the design files and the CAD files, then the location of firefighting equipment is not noted. And we would often send that back to the client and say, can you indicate existing or proposed firefighting locations? Call points, for instance, manual release equipment requires a 5 lux minimum as well. So it's important to really capture that information, consider it in the design to ensure we're doing everything we can. So there we are, quite a significant comprehensive view of all of the designs and all of the standards and we can take some questions perhaps now.
Okay, so thank you, Colin. We're now going to move on to the Q&A session. We've had quite a few interesting questions come through. So the first one, Colin, is how can we as architects go above and beyond standards and regulations when specifying emergency lighting?
Right, yeah, I mean it's a very good question, of course, because I touched on it a couple of times throughout the presentation, talking about the standard having one measure. For instance, BS 5266 talks about minimum requirement of 1 hour duration for emergency battery life within emergency luminaires. And as an industry, the lighting industry really have just moved on to 3 hours as being a almost de facto standard. So there's a good example, but there are other parts of the standard that encourage people to go above and beyond as well, and go to good practice rather than minimum requirements on levels. And so that good practice part is really a key. I think a key, as in most cases where people are trying to comply with standard, and at the same time trying to adopt best practice, as architects, I think the key is to get your client to pay for it. Quite frankly, because typically going above and beyond requires extra cost. But unlike normal mains lighting and emergency lighting, it's becoming so much critical, and there are plenty of incidents across the last few years that have created, hopefully, a culture of going above and beyond for emergency lighting provision rather than just meeting the minimum standards, and that will encourage clients to fund it properly as well.
Excellent. Do you think there are any areas of the standards that you have mentioned today that fall short of today's fire safety requirements?
No, they're pretty comprehensive, and they've only recently been reviewed, if you like, and the ICEL board within the UK, who are predominantly there, an industry-led body, used to help shape emergency lighting standards, closely monitor technology, building standards, feedback from end clients and from health and safety consultancy bodies to make sure that the standards are as rigorous and as practical as they can be. So, we're pretty confident that the standards are right.
Okay.
I think the gap is really, application of those standards.
Yeah. Okay, perfect. Move on to the next question. So clearly the protection of building users takes precedence over looks, but do you have any essential tips on marrying safety elements like emergency lighting with the aesthetics of a building?
Yes, I think the answer for perhaps, any new building would be that, there is enough range of luminaires now from most manufacturers to suit and blend in with most modern building applications. So if you are able to, for instance, one of the more popular products in the market these days is a circular recessed emergency downlight that is no bigger than 70-80 millimeters in diameter, and optically, because it's an LED light now, providing emergency lighting, you've got a much smaller light source. You can control that with clever optics to allow a circular product to provide a light level up and down an escape corridor to a very high level of performance. And that's the most discreet and unobtrusive product you can get compared to some of the larger bulkheads that were used to do that job. And that was because the larger bulkheads were based around a fluorescent technology, which involved something like a 200 millimeter long fluorescent tube. So they didn't look particularly great because of the nature of the light source. But as the light source has changed to being much smaller, then we're able to make them much neater and blend in with installations a lot easier. It becomes a bigger challenge in older buildings where you can't recess and you have to go surface fix. But again, there are enough range of products, I think, on the marketplace to cater for that and find that right balance.
Excellent answer. Okay, so what do you think will be the next big change in these standards for emergency lighting?
Well, as I said earlier to the previous question, we've got a pretty good handle on what the requirements are and that they're up to date. I think one of the changes that we're seeing in building use, of course, perhaps post-COVID, there could be two considerations. Certainly the cleanliness of the building might mean that there's more equipment in rooms, in classrooms, that are maybe checking air quality. It's early days to look at that, but that may impose some additional requirements that we have to think about in the lighting world. And then the other consideration is the multi-use of buildings and rooms, particularly offices. And so as that use changes, which it may do post-COVID, hybrid working, all of these different terms and phrases that are being used in the immediate aftermath of COVID are being explored currently. And there's a 2-year plan, if you like, or certainly timescale, where a lot of the implications of hybrid working and all of these phrases are going to impact upon building use. So we've got to stay on top of all of that, make sure that the recommendations are up to date and taking into account some of those changes. And so it's building use change that would really shape the standards in the emergency lighting world.
Yeah, that's understandable completely. Okay, so technologically, what do you think will be the next innovation in emergency lighting?
Yes, we're already seeing as a mature technology, but it's making customers aware of it. So perhaps the whole of the audience aren't aware of the technology that's available. Is to take advantage of smart technology, wireless technology, particularly specifically in emergency lighting testing. Typically in larger buildings, universities, large office buildings, or large manufacturing facilities, there can be up to 200 dedicated emergency lighting luminaires, all of which need inspected and tested at regular intervals as part of the standard. And so providing that and doing that can be costly, can be very fragmented as well. Different people's got different responsibility. So having the operation and the testing of the emergency lighting to be done remotely, so that each dedicated emergency luminaire is wirelessly sending data and signals and information about its state of operation across a wireless network, is a huge technological leap that we're already seeing in many installations now, universities, office buildings. And so it enables, for instance, there is a university in the UK who have close on 20, 30 different buildings across a single city. And the services engineer in the central location can test all the emergency lighting across his estate in the city overnight on a weekend without him being on site. He turns up in the morning, looks at the test report, and it's all been done wirelessly, remotely, sent back to a central data point, and he can review it from there. So that kind of technology is really available now, and people are beginning to see the benefits and taking advantage of it.
Yeah, excellent. Very high-tech stuff.
Oh, it is. It is.
I suppose it's, in a way, it's more eco-friendly because there's less travel. In a way, it's done remotely, so
and it's
that's another benefit,
the beauty of it as well is it's very thorough. It's you're not relying on an operative to do that. It's technology doing it, technology taking care of it. There are obviously protocols to make sure that it is reliable, but it's all of that's been tested and proven, and it's also relatively cost effective to install as a system as well. So it ticks a lot of boxes. It really does.
Yeah, it's beneficial all round, really.
Absolutely.
Okay, I think we've got time for one last question. So, okay, so thanks for your presentation, Colin. It's been really enlightening and beneficial. Evidently, there's been some invaluable advice imparted today, but if there's one single nugget of wisdom to take away from this webinar, what would it be?
Yeah, it's. I'm first of all tempted to say perhaps something that the audience might know anyway, and that is to, just ask as many questions about the people in the building that you're lighting as possible. But that's fairly obvious, I think, and people wouldn't perhaps thank me for saying it in that way. From a manufacturer's point of view, what are we after when our clients engage with us and want to design and are looking to find a solution? Then the nugget of wisdom, really one of the the key points that we're often trying to explain to the customer is that you've really got to know a lot about the product that's going into your building that's providing that level of security. If there's one weak point, one failure point, one bottleneck in the whole of the safety of your building, then it is in the technology inside the luminaires. And so, getting that validated, getting that checked, getting that referenced by whoever's providing your emergency lighting. The old phrase, of course, is very true in lots of buildings for lots of different materials, not just lighting. Buy cheap, buy twice is often the phrase that's used. And that would be the nugget of wisdom, really. You get what you pay for when it comes to emergency lighting. And if you're going to make shortcuts in your building provision, emergency lighting is just one of those that you cannot afford to take shortcuts on. And so that would be the nugget of wisdom to take away.
Yeah. Perfect. Excellent. Thank you very much.
Thank you.
I hope you found that all very useful and informative. I'd like to thank Colin, our speaker, for his time and imparting his knowledge. And I'd also like to thank you, our audience, for taking the time out and sending across all your questions. Thank you, everyone. Goodbye.